Welcome back to Tech Pulse, the show where we break down the latest and greatest in science and technology, making it understandable and, yes, even fun. I'm Zaper, here to guide you through today's cosmic headlines.
And I'm Puck, your quick on the trigger question asker, making sure we don't get lost on the jargon. And hey, before we dive in, hit that subscribe button so you don't miss any of our future space and tech deep dives.
All right, let's get into it. Today's big story. Perseverance explores Mars's oldest rocks for life clues.
Whoa, oldest rocks? That sounds ancient, like 4 billion years old?
Exactly. Perseverance is venturing into terrain called megabreccia, basically chaotic piles of broken rocks from asteroid impacts, which could hold secrets from the very beginning of Mars's history.
Okay, pause. First, megabreccia, that's a mouthful.
Right. Break it down. Breccia is just a rock made of fragments of other rocks. Mega means these fragments are huge, some as big as football fields theoretically. These rocks were shattered and thrown around by catastrophic asteroid impacts.
And these aren't just random rocks. Some could be from deep inside Mars's crust.
Exactly. Think of it as a cosmic smoothie of Martian history, where chunks from various depths and ages all get mixed together.
Got it. And Jezero Crater, where Perseverance is roaming, isn't that the delta with all the sediment deposits we've been hearing about for years?
Yep, Perseverance has already explored those sediments and some volcanic rocks. But this megabreccia is older, potentially the oldest accessible rocks the rover has found so far.
So last week, Perseverance crossed a ridge called Soroya Ridge and started investigating this chaotic megabreccia terrain at a location named Scotiafjellet.
Scotiafjellet. Love the names. Sounds like a place you'd go skiing.
Right. But on Mars, it's all boulders and broken rock fragments. NASA's mission update says the rover is using its full suite of instruments to examine these rocks.
Full suite, meaning cameras, spectrometers, drills, everything?
Everything. They're looking at composition, mineralogy, and potentially signs of ancient water activity, which is key in the hunt for past life.
And speaking of past life, NASA is going to discuss a sample called Sapphire Canyon soon.
Yep, collected in July 2024 from rocky outcrops along Nertiva Vallis. It has these distinct spotted patterns. On Earth, patterns like that sometimes hint at microbial activity.
Exciting, but also cautious excitement, right? We can't just jump straight to Martians existed here.
Exactly. It's always measured.
So the megabreccia could connect Jezero's local story to Mars's bigger history. How does that work?
Think of it like putting together a jigsaw puzzle. Jezero's delta shows local water activity. Megabreccia shows violent asteroid impacts from the Isidis Basin, which scattered deep crustal rocks across the region. By studying both, scientists can see how local and planetary scale processes interacted 4 billion years ago.
And Mars's interior. InSight mission found massive chunks still embedded in the mantle.
Yes, some up to 2.5 miles in diameter. That suggests Mars's interior hasn't been recycled like Earth's. Plate tectonics on Earth constantly turn crust. Mars has stayed relatively static.
So these megabreccia rocks might actually be pristine windows into the planet's earliest crust.
Exactly.
And a sample return. NASA wants to bring these rocks back, right? But that's complicated.
Very. Mars sample return is facing budget issues and timeline delays. Costs could hit $11 billion, and samples might not reach Earth until the 2040s.
Oof, patience is a virtue, even in space exploration.
Let's spotlight a few numbers. Jezero Crater's delta and volcanic rocks are younger than the megabreccia, meaning these new rocks are more than 4 billion years old. The Isidis impact crater that scattered some of this material is 1,200 miles wide, and Perseverance has collected 30 samples since landing in February 2021.
That's a lot of data, like a Martian library.
A library 200 million kilometers away.
Also, the distinction between different rock types, surface versus deep crust, is critical for evaluating water history and potential life. That's science in action.
All right, that's today's Martian update. Perseverance exploring some of Mars's oldest rocks, hunting clues about early water and maybe life.
If you enjoyed this deep dive, make sure to like, comment, and subscribe. And hey, tell us what you think. Could these megabreccia rocks finally give us a glimpse into ancient Martian life?
Thanks for tuning in to Tech Pulse. Until next time, Keep looking up and stay curious.
Catch you on the next one.